So we can talk about the glomerular filtration rate, or the regulation of how much fluid is filtered into the nephrons in a given unit of time. So this is sometimes referred to as GFR, and it is really important measure of how well your kidney is functioning. So when we look at the GFR, it is for both kidneys, it is normal is about 120 to 125 milliliters of filtrate per minute for both kidneys. Now, if the filtrate rate isn't high enough, then perhaps you're going to get buildup of waste products in the blood, and that could be bad. If it is excessively high, like if you have producing too much filtrate, then one of the things that can happen is that your nephrons can't or don't have the time to actually reabsorb all of the good stuff from the filtrate before producing urine. So you lose stuff in your urine. Also, if there's excessively high pressures in your glomerulus, you can sometimes damage the glomerulus. And so that could also lead to kidney damage and the kidney stopping to function properly. So when we look at this filtration rate, you'll remember that I talked about how there are certain things that are responsible for pushing fluid out and sucking fluid in. And so there is a diagram in your book that shows something that looks like this. So this is the hydrostatic pressure coming into the glomerulus. And you'll notice that it is higher than the osmotic pressure that is sucking fluid back into the capillaries. And it's actually higher than the pressure that is just found within the nephron. So that would be like 45 versus 55. So your net filtration pressure is 10 millimeters of mercury. So what that means is the net filtration pressure is going to force fluid out. So it is the net filtration pressure that forces fluid out of the glomerulus and into that glomerular capsule. So we need mechanisms to regulate these pressures. And one way that we can regulate it is by changing the diameter of the afferent arterial. So like if we constrict the afferent arterial, then less blood is going to come into the glomerulus. So the pressure is going to be lower and there's going to be less fluid leaving the capillaries. And if we dilate it, it's actually going to increase the glomerular filtration rate. So if we constrict or constriction of afferent arterial is going to decrease the net filtration pressure, and this is going to decrease the amount of filtrate produced. If we dilate the afferent arterial, then more blood is going to flow into the capillaries, and it's going to be, because more blood is coming in, it's going to be higher pressure. And so then we're going to increase NFP, and we're going to increase filtrate production. So we have some mechanisms in place that are homeostatic feedback, negative feedback mechanisms that help to regulate the amount of filtration pressure on this membrane. Because remember, if it's too high, you could actually blow out the membrane and you might get blood in your urine. And if it's too low, then you're not going to have enough urine production. So like in people that have like really small amount of urine production and they're not producing enough urine, it could be a problem with the blood pressure as well. So blood pressure also influences this as well. So let's look at what are referred to as the two intrinsic mechanisms for regulating GFR. Okay, so two intrinsic, that means it's inside, like right there inside the kidney, mechanisms for regulating GFR. One of them is called the myogenic mechanism. Myo means muscle generating. And so this is the idea when smooth muscle in a blood vessel gets stretched, it actually automatically will contract. So stretching of the arterioles will cause it to contract. And likewise, when it's not stretched, it actually dilates. And so this regulates the diameter of the afferent arterial and regulates the amount of blood that's going into the glomerulus, which is going to affect the pressure, which is going to regulate or affect the amount of filtrate that is produced. So this is the myogenic mechanism. The second mechanism is called the tubular glomerular mechanism. Tubuloglomerular, these words. You can break them down. So tubulo means like it's in a part of the tubule. So something about the inside of the tubules is going to go back and affect glomerular filtration. And so we have a specialized set of cells called the macula densa. These are cells that detect salt levels, NaCl levels in the filtrate. Now, salt is one of those things that we actually like to reabsorb. So if there is too much salt in the filtrate that's going out and going to become urine, then that means your glomerular filtration rate is too high. So too much NaCl, GFR is too high. So we want the filtration rate not to be so high that we don't have time. The nephrons don't have time to to figure out what it is that they want to take out of the filtrate. So let's look at that mechanism. So this is my glomerulus. You'll notice that this is where the macula densa cells are located, and they can detect the amount of salt in the ascending limb of the loop of Henle. So this is the filtrate already gone through the proximal convoluted tubule, and a lot of salt is reabsorbed there. So this can detect too much salt. This is the macula densa is actually part of, so I need to write that down. You need to know this. The macula densa is part of the juxtaglomerulus apparatus. And we saw, don't confuse this with juxtamedullary nephrons, but this just means that it's an apparatus that is next to the glomerulus. So this whole thing is the juxtaglomerular apparatus. And what these macula densa cells are detecting are salt levels. And if the salt is too high, then they're actually going to cause constriction of the afferent arterial. So high salts, this is going to cause constriction of afferent arterial. And what this is going to do is this is going to decrease GFR, the glomerular filtration rate. And so that is when, those are actually two mechanisms, intrinsic mechanisms for how glomerular filtration rate is influenced. So when we talk about extrinsic, we can talk about just blood pressure in general. So we could talk about how the sympathetic nervous system influences the diameter of the blood vessels, and how that could also affect the functioning of the kidney. So we'll talk about the extrinsic mechanism next.